I think the session description indicated that I was going to mix in a lot of multimedia with this presentation. Unfortunately, I didn't get around to doing that. I was inspired to do this presentation because I was going through some old tapes of when I attended like Linux World back in 1999. And I didn't realize at the time how historic those particular conferences, 99, 2000, I didn't realize at the time how historic they would be. And there I am videotaping Linus Torvalds' keynote address and things like that. And so as I was going through this, I thought, I should do a presentation that really leverages this video that I've got and other online video. But as I started going through this, I realized I didn't really have time to do that correctly. And so this is really going to be more of just a plain history lesson. We've only got 50 minutes. But my interest here was that there's a lot of people who have gotten into the open source community, into the movement in the last, say, 15 years that don't realize what came before that and what led up to that. So whether you are, a 30-year veteran or if you're kind of a newbie, this will give you a little bit of background. Some things some of you may know already, but I'm hoping this will be kind of a history lesson for you. Any questions before we get started? Okay. Well, what I wanted to start with, let's see. There we go. When you look online and you read about the history of open source, a couple of the things that come up are these user groups that surrounded some hardware. The A2 by Univac was kind of an early to mid-50s system. And then Share, which still exists today, is like an IBM user group. And Decus is another one that's still somewhat relevant today, which was users of digital computers like the PDPs and the VACs, mini computers and so forth. But these groups used a lot of, hey, I found this solution, I wrote this script, this is how I did to solve this problem. Don't you love that? Like a little rat wheel right up on top of the projector there. And so there was all this sharing of solutions, sharing of code. So this idea of sharing knowledge, sharing information, sharing tools is not a new one. Something interesting happened. A few interesting things happened in 1969. I'm sure there were lots of interesting things that happened every single year, but I thought 1969 was really interesting because, number one, we have man landing on the moon, which was an enormous scientific and engineering feat. A lot of technology and knowledge and tools went into making that happen. At the same time, the Defense Advanced Research Projects Agency decided to create a nationwide network of computers. At the time, their initial plan was just 4 locations. They were going to have 4 nodes on this ARPANET. But what's really interesting about the ARPANET, which was formed in 1969, is that the standards, the process by which the ARPANET would be operated was controlled by a process called RFCs, requests for comments. And so if somebody had an idea for how email should go from one place to another, they would publish an RFC. And then people would comment on the RFC, say, well, I don't like this aspect, or you're going to run into problems on that. So even though this wasn't, putting something on GitHub and letting people, commit to it and so forth, it was a really unique and groundbreaking way of building things, because these RFCs came to be the standards by which the internet was based. The ARPANET grew and grew and grew, and around, I want to say 1980, the National Science Foundation established the NSFNet. The ARPANET became one of many networks, which then later became known as the internet. So it was the great granddaddy of what we have today. Also in 1969, Unix is created. And Unix, of course, led to lots of things, including BSD, lots of commercial Unix distributions, and of course, our baby Linux. Coincidentally, the creator of Linux is also born in 1969. Linus Torvalds, born in Finland, and we'll learn more about him in a little bit. Any questions so far? Okay. 1970s, Unix is developed by AT&T Bell Labs. They distributed it for free to academic and government researchers, sold it to commercial entities. Dennis Ritchie and Brian Kernighan were two of the main researchers working on this. In 1973, they rewrote Unix in a new programming language called C. And this made it very portable. And so one of the AT&T researchers went and did a research sabbatical internship something at Berkeley and shared the stuff that he'd been doing at Bell Labs. And Berkeley created their own Unix distribution, which later became known as BSD. The Sun Microsystems based their original Unix on that. A lot of different commercial variants were based on that fork of Unix from 1975. A lot of, and we'll find out a little later, a lot of individual software packages were developed at Berkeley, which later became kind of the foundation for what we use on the internet today. 1970s, companies started to spring up to leverage this Unix operating system, but I made a note here that they also started to close it off. They started to, put up walls, what you can and can't do with it. 1980s, there's a lot of stuff that happened here, but I just wanted to point out that one thing that really grew a lot during the 1980s in the academic circles was Usenet. And who here has used Usenet? Just a couple people, I'll bet. I mean, when I first started using the internet in the early 90s, it was the place to be. Usenet and mailing lists. And sometimes they were one and the same. But Usenet is kind of, it's died off. Nobody really uses it much anymore. But during the 80s and the 90s, it was kind of like a widely distributed bulletin board system of tens of thousands of different topics that could be discussed, and it was very actively participated in. Now we have Facebook. So you can think of Usenet as the Facebook of the 1980s for a very select, geeky group of people. A lot of information was shared on Usenet, and it became a messaging and collaboration platform for a lot of different projects. I mentioned UUCP and FidoNet here because during the 1980s, of course, very few sites had real-time, always-on internet connections. But, of course, people still wanted to leverage the knowledge that was available there. UUCP, which stands for Unix to Unix Copy Program. And this was a way of using like dial-up links between nodes to send email and grab and send information for Usenet newsgroups and other. You could say, I want this file sent to this other system. And so UUCP was one of these other less connected means of exchanging information. FidoNet was more of a way of exchanging information across bulletin board systems. And once always-on connections came to be the norm in the mid to late 90s, both of these just kind of disappeared. There really wasn't much use for them anymore. One very important thing that happened, let me see, I seem to remember that one of these, there we go, that's better. One really substantial thing that happened in the 1980s was this guy, Richard Stallman, commonly known by his initials, RMS. He was working at MIT during the 70s in their artificial intelligence lab. And he became very enamored with this idea of sharing software. And by about 1983, he had this idea that that he could write a version of Unix that was completely free of copyright, completely free of anybody's claim that you couldn't, we will determine what you can and can't do with this software. And so in 1983, he posted to the Net Unix Wizards news group. This is an excerpt of what he posted. He said, starting this Thanksgiving, I'm going to write a complete Unix-compatible software system called GNU. And GNU is one of these self-referencing acronyms that we often see in the open source world. It just stands for GNU's not Unix. And he says we're going to give it away free to everyone who can use it. And at the time, I don't think he really fully comprehended the idea that projects like this could benefit greatly from collaborative contributions. I think he was seeing, well, me and a few of my friends will work together on building this Unix system, and we'll just give it away and everybody will enjoy it, and everybody will be happy. But progress on GNU went really, really slow. At first, there were things that were built. He had written by this point an editor, which kind of became an operating system all in itself, called Emacs. Has anybody used Emacs? Anybody have really fat pinkies? Okay. Emacs is a text editor that really leverages your ability to type different key combinations to do all sorts of stuff. But it's not just a text editor. It's also a psychotherapist. It's also an email reader, a news reader. It does pretty much everything. It could be your web browser. It can be a lot of different things, but it started out as just being a text editor to be a tool used in the GNU Unix distribution. Along the way, they created the GNU C compiler, which is one of the best compilers available, the best as far as like free tools goes, and other lexical parsers and things that you need to build a Unix operating system. So they were making their way towards this grandiose end goal of a free Unix. Some other things that happened during the 80s. Donald Knuth, who's he's a famous computer scientist, created a layout language called TeX. And in the electrical engineering world, this circuit simulation program called SPICE was developed. These were both developed without any preconceptions about, hey, we're going to develop this and get rich. These were all developed in a very academic setting where we're going to develop this. In some ways, they were designed to help people learn how to do things, especially in the case of SPICE. The X window system has an interesting history. It was developed in an academic setting, but it was kind of taken over, in a sense, by some of the commercial interests. Sun Microsystems, HP, SGI, all kind of had their hands in it. And it had an interesting future. We'll get to that a little later. Come 1991, Linux is born. And this has a really interesting history. Some people that haven't read the details here think, well, Linus was just a computer science student and decided to write a Linux kernel, and away we went. His history is interesting. He had never even owned a PC prior to 1990. Now, that's not to say that he didn't own computers. He actually did a lot of hacking in his youth, but on less common computers. He'd actually gotten in and done some assembly type programming on Commodores and Apples and some Altair, really archaic architecture compared to what we use today, and especially to the PC platform. But that gave him some experience of doing some really low-level programming and understanding of the architecture of computers. But he had never really been exposed to PCs before 1990. In 1990, he bought a PC, and he was just tinkering, really. I think he was running DOS on it. He wanted to run a free Unix, and so he downloaded Minix for the 386. And Minix was developed by Tannenbaum. He was another European guy, and he had created Minix as a teaching tool, just like some of these other projects were created as a teaching tool. He created Minix so that people could learn how operating systems worked. He really had no... one of the problems was that as people used Minix, they're like, this is really cool. Can you add this? Can they'd find little problems with it, and they would send him email and say, can you fix this? Well, he really had no interest in doing this because all he wanted was a teaching tool, and he didn't have the time. I mean, here he is a professor at some computer science department in Europe, didn't really have the time, the interest, or the vision to see this take off. And had he realized that, if I kind of spread the load and delegate this with people who are interested and have the skills to do it, today we might be, celebrating another operating system than Linux. But it was because of Tannenbaum's reluctance to, kind of grow this project of his into more of a collaborative platform that Linus said, I'm going to release this thing that I've been tinkering with that is a lot like Minix. He ran Minix on his computer for quite a while, actually in parallel with Linux, because he was kind of using it to kind of see how things were done. Here's the announcement that Linus made to the Minix news group, and it's pretty amusing when you read it now, where he says, this is just a hobby. It won't be big and professional like GNU, but he's just writing an operating system for AT clones. How long has it been since you've heard that term? This has been brewing since April, and it's starting to get ready. I'd like to get any feedback on it. And so he says here he's ported Bash and GCC. These are two projects that were created for the GNU system, and things seem to work. This implies I'll get something practical within a few months, and I'd like to know what features most people would want. So there are a lot of really interesting things here. First of all, he's doing something that Tannenbaum was very reluctant to do, and that is solicit feedback and say that, I want to use your feedback. I want to build something that other people are interested in. He says here, this is not Minix. I haven't used any of Minix's code, but it has a multi-threaded file system. It's not portable. it's interesting that he says that here, and we'll learn, if you learn the history of Linux, you'll find out that when that changed. But at the time, it was just for 386 hardware. And I'm surprised, actually, that it actually supported hard disks. I guess it supported an IDE hard disk, and that's all he had at the time. So it's interesting, that first version of Linux that was put out into the wild, October 1991, the compressed code was 63 kilobytes. And by today's standards, it didn't really do very much. But it's interesting, by January, so 3 months later, it had almost doubled in size. Version 0.95, we're seeing, a little bit more creep, April, September. What's interesting here, we see a big jump. It's more than 10 times the size when we get up to, yeah, it's quite a bit larger when we get up to version 1.0, which is 3.5 years later. But all during this time, up until late 1993, there was no networking. And that's kind of baffling to me still, that there was no TCP/IP stack for connecting to the internet. What people would do is they would download images of 2 floppy disks, a boot floppy and a root floppy. And what you would do is you would put in your boot floppy and boot your computer up, and that was the kernel. And then once that was finished, you'd put in your root floppy, and this contained the bare bones file system and the GNU utilities that you would use, like your editor and your shell and whatnot. And then you were using Linux. And so people would, they'd run Windows or DOS or some other operating system on their computer, download these floppy images, and then they would play with Linux as kind of like a standalone operating system that really had no connection to the outside world. And then they'd hack on it and then take the changes that they'd made and send them to Linus, and if he liked those changes, he would incorporate those into the kernel. Early on, people were saying, well, if we combine this Linux kernel with these utilities that Richard Stallman has created for GNU, we can create a distribution of Linux with other programs that make it even more useful. And it's a Linux distribution. And the first one was SLS. No, it's not the first one. It's one of the very first ones that really kind of broke out all on its own. And SLS had the same idea of the boot and root floppies. But SLS was just one guy. I can't remember his name right now, but he, of course, started getting peppered with people saying, I'm having this problem, I'm having that problem, or people saying, I really like this, can you add this functionality, and so forth. And he's like, I just don't have time for this. I've got a life outside of SLS. So SLS kind of died, but there's a whole branch of operating system distributions that fanned out of SLS. People that were willing to pick up the slack, pick up where he left off. Slackware is one of those. SUSE Linux, which is now owned by Novell, was another one that came out of SLS. Does anybody know how you say that? Yggdrasil? Okay. This was the first one that was distributed on CD. So we're talking like 1992, and not very many people had CD-ROMs then. But they realized early on that this was the future of distributions. And they had a distribution, I think it was $69 or $99, and they'd send you a CD. Unless, of course, you were one of the original contributors to any of the tools that were on the CD, then they'd send it to you for free. So that was kind of their way of saying, if you contribute to the open source community, except they didn't call it open source. That's one thing that today we forget that the term open source is only about 14 years old. It was created about 1999, and prior to that, nobody really knew what to call this phenomenon of code sharing, and the only person who'd really put a name on it was Richard Stallman, and he called it free software. And people thought, free? That's great, I don't have to spend any money on it. He says, no. It's not free as in beer, it's free as in source. It's free as in speech. Free as in source. So the term open source hadn't come around, but a lot of people had that whole problem, because the first time that you say free software, especially here in America, we don't think of free as in freedom, we think of free as in how much is it going to cost. So Debian was also very early on in the game, and Debian took the approach, we're going to create a distribution in much the same way that the kernel has been created. So it's going to be very community-oriented. We'll have somebody who's in charge, but they're going to delegate work to other volunteers. Red Hat they had their first release in early 1994. And another early player here was Caldera, which was right here in Utah Valley. Caldera was a great company early on, creating Linux distributions, and they just had a very unfortunate end. I'll leave it at that. I actually wanted to have a slide here all about Caldera, and I realized I don't know quite enough, but if we have time, maybe we can talk about it. Okay, well, what else was going on here? I mentioned before that at Berkeley, they were kind of creating their own Unix based on what Bell Labs had done. But BSD had kind of become tied down by people saying, I have copyright on this, and I have copyright on this, and you don't have the right to distribute this, and so forth. So in 1993, Unix System Labs versus BSDI was settled. This was one of the reasons why Linus was reluctant to implement the BSD networking stack in Linux for version 1.0. The BSD networking stack was really good, and people were saying, well, let's just include this because it's a really good networking stack. And he says, because of all the lawsuits that are going on here, I don't want Linux to be affected by that. And so he had Alan Cox write a networking stack for the Linux kernel, which some people would say was inferior to BSD for a long time. I think the tables turned probably about the mid-90s. Linux has a networking stack every bit as good as BSD, if not better. But once that was settled, BSD was free to go and become another open source operating system. And so we had three very predominant distributions of BSD Unix that came out of that: NetBSD, FreeBSD, and OpenBSD. OpenBSD played a big part a little later in our story, but they're all free and open source distributions. Some important server software came out during the 90s. Apache web server, probably the predominant web server on the internet today. Perl. PHP, which was originally written in Perl. Sendmail. Now, you remember I talked about UUCP? Sendmail is a good example. Some people, if you've done any system administration on a Unix box and you try to configure Sendmail, you might find yourself really overwhelmed by the plethora of options available for Sendmail. And the reason why was because Sendmail was developed during the 80s, when any Unix system connected to a network, it might be a UUCP network, it might be BitNet, it might be if you're really lucky, you might be connected to an ARPANET node or an NSF node or something like that. So Sendmail had all these configuration options that would allow you to send email a variety of different ways. Bind, the Berkeley Internet name daemon, is the big 900-pound gorilla when it comes to DNS. And OpenSSH, I have a slide on that. Apache is really interesting, the history of Apache. Does anybody remember NCSA and their role in creating one of the first web browsers, NCSA Mosaic? This is probably 92, 93. The web was pretty young at the time. They also created a open source and distributable web server called NCSA HTTPD. And this was a predominant web server. But when Netscape came to be, Netscape was this company that was going to change the world and do all kinds of stuff. They had a free web browser called Netscape Communicator. But they also had a whole line of web servers. And that's where they intended to make their money. And so they hired away a lot of the engineers from NCSA that had been working on the HTTP server. And as a result, the community around the community effort that was developing NCSA kind of died. Brian Behlendorf was working out in California. He was previously a student at Berkeley, but he was working for Wired magazine on their Hotwired project, which was, at the time, they were like, we want to have a internet presence, but we're not really sure how or what that means. So they set up a Gopher server. And as they set up a Gopher server, and then they said, well, this HTTP thing looks interesting. And so they used an NCSA HTTP server and set up a website. And within a few months, it was getting quite a few visitors. Brian noticed that things were not getting done on the NCSA HTTP server. And so he sent out kind of a rallying cry online saying, let's take all these patches and fixes that have accumulated and haven't been worked on, and let's fork NCSA. And so they created Apache. And Apache was just the name of some project that he was working on, but people really liked it because the web server was a patchy server, because they'd taken all these patches and patched it together, so it was an Apache server. Sendmail, as I mentioned, was developed in the 80s, and DARPA standardized on BSD Unix as they started building out this network of academic nodes, and so BSD shipped with these Unix systems that were there, and Sendmail was included. And as I mentioned, Sendmail's very versatile and diverse configuration was played a part in its being used quite widely. Today, it can be a configuration nightmare. The Sendmail book, for a long time, before the Python book came out, Sendmail book was the largest, thickest book that O'Reilly sold. But I think the Python book is thicker. But nowadays, if you're setting up a box to send and receive email, you just use Postfix or Exim or something, because they're so much easier to configure. But then at the same time, they don't have support for UUCP and all that other stuff. So Bind was also developed at Berkeley. This was the internet name daemon. And it became the de facto DNS server. Most people use it today. There are alternatives, but Bind still reigns supreme. OpenSSH. It's interesting. I remember in the early 90s, any time we wanted to connect to another system, log into another system, we'd use Telnet. Anytime you wanted to transfer a file from one computer to another, we'd use FTP. Or if you were in a closed network, you'd use RCP or rlogin or something like that. Excuse me. Because with our RSH and RCP and RLogin, you could actually connect to a computer without putting in your password. It was really convenient. But the problem was, and I remember, I was up at Utah State in the early 90s, and I remember that it was fairly trivial if you were in like a computer lab. We didn't have network switches, we had network hubs. And one of the features of a network hub was that traffic to any port was repeated to every other port on the hub, because they didn't have the ability, they didn't have chips inside those to route traffic from one port to another. So they just sent traffic that was coming in on one port and sent it out to all the others. So it wasn't until the late 90s that switches came about. But what that meant was that if somebody was typing in their username and password and to connect to another computer, it was going across the wire in plain text. Anybody with the program that was sniffing the wire and watching packets go across could grab anybody else's credentials. It was quickly realized that we need something that encrypted those credentials. And not only that, encrypted all the other communication that was going across. So Tatu, whatever his name is, Ilonen, released SSH in 1995. And SSH was basically a drop-in replacement for things like Telnet and FTP and RCP and all those that encrypted things. And the first version of SSH was free. He gave it away. The source was also shared. But as it started to grow in popularity, he said, I'm going to set up a company. And, excuse me. And by the time he got around to releasing SSH2, he had a whole new licensing scheme around the software. Excuse me. It was free to use, but access to the source was somewhat restricted, and you certainly couldn't use it in any other projects. So the OpenBSD folks took an older version of SSH that didn't have any kind of licensing issues, and they said, we're going to create a new project called OpenSSH based on that, and they implemented the protocol and everything that had been implemented in SSH after that. And now OpenSSH is far distributed and used far more widely than the original SSH. So this term open source, as I mentioned, free software wasn't going to cut it. Because I remember people confused free software with freeware, which was stuff you could download for your computer, like, hey, I got this card game, it's freeware, that sort of thing. Also, a lot of the freeware was plagued with viruses and malware, and some of the stuff was free, but it installed all kinds of other crap on your computer. So they didn't want this misunderstanding between the software that was free as in freedom, free as in source, free as in speech, to be confused with this crap that was, your free card game. In, I'm going to say early 1999, it might have been late 1998, Eric Raymond published The Cathedral and the Bazaar. Eric Raymond was, he had published a book called the Hackers, what was it, the Hackers Dictionary?
Sounds right.
Yeah. And it basically explained everything about the free software, the open source culture, in a way that anybody who wanted to participate could read this thing and understand how things worked. He also took over a project called Fetchmail that was responsible for grabbing mail off servers and doing things with it. So he had a fair amount of experience in the open source phenomenon. But he published this essay called The Cathedral and the Bazaar. And in this essay, he explains how a company could benefit from giving away their source code. And at the time, Netscape was kind of in a head-to-head battle with Microsoft for dominance of who had the web browser that everybody was using. I think some of you may remember that when Windows 98 came out, Microsoft shipped it with a web browser, a full-featured web browser. that did everything. And people like, Netscape said that's not fair, especially since you couldn't uninstall it. It became an integral part of the Windows operating system. And so it was like, why would anybody even install Netscape on Windows 98? Well, because it's a better browser, but there really wasn't, for somebody who didn't know that, they would just go on using Internet Explorer. So the folks at Netscape attributed their decision to open source their browser to Eric Raymond's essay. And they created an open foundation called Mozilla. So Mozilla is born, and Netscape says, we're going to give this away. Eric Raymond, Bruce Perrins, who was one of the early contributors to Debian, and a few other guys get together and they create the open source initiative. And along the way, they say that open source is what we should call this phenomenon, this movement. And so it was probably around late 1998, mid 1999 that the term open source started to become used. Another, almost a repeat of the Netscape experience was what happened to StarOffice. StarOffice was a cross-platform office suite developed by a German company called Star Division. And I didn't realize this until I did a little bit of research on this, but they were actually creating StarOffice as early as the mid-1980s. They were creating it for your little Commodore-type computers and things like that. But by the late 90s, they had a cross-platform office suite that would run on Macs and Windows and DOS and a few other things. They were acquired by Sun Microsystems in 1999, and they made the StarOffice 5 was available for Linux and the Solaris and Sonos and all of the really big operating systems like Windows and Mac. But between 1999 and 2000, Sun kind of came to the same realization that Netscape had a year previously. And that was, this needs to go out to the community. If we ever want a chance to compete with Microsoft Office, because the community is where all the improvements will be made at a pace that will benefit the software. And so they released StarOffice source code, and it became Openoffice.org. And how many people have used Openoffice? I mean, for what it is, it's a great piece of software. But it tries to do a lot of stuff. I'm using it right now, in fact. In 2010, there was a little bit of friction within the Openoffice community. I think mostly because they thought the project itself should be more vendor neutral. Sun had kind of kept his hands in there, and Sun had been purchased by Oracle. And I think a lot of people saw Oracle as really bad.
They weren't all that great. They've gotten better.
Oracle's redeemed themselves a bit, but at the time I think a lot of people were scared what would happen to OpenOffice under Oracle's leadership. But there was kind of a fork of OpenOffice created called LibreOffice, and almost everybody jumped ship from OpenOffice to LibreOffice when that happened. So now LibreOffice is what pretty much everybody uses. And that's my presentation, and I timed it perfectly. Any questions?
Yeah. Just because I don't know much about it, I haven't looked into it, but ARPANET was sort of the first network structure, they put that together, but then it went into DARPA. And so where did that transition happen, and how did that affect the software that was being used? Because from what I understand, when it went to DARPA, they were still using all the same tools, the same infrastructure, but now it was just government sort of.
Well,
Extensive, right? Well, the DARPA was for it from the beginning.
Yeah, DARPA was the one that created the project in the first place. But what happened in the 80s was that what we saw was lots of different DARPA-like networks. Once the ARPANET kind of proved itself, you saw lots of different networks that were connected to each other. And so you had the ARPANET, you had the MILNet, which was all military, you had the NSFNet, which was academic installations and research facilities that were funded by the National Science Foundation. And then, of course, you had you had regional networks like WestNet here in Utah, which basically connected us to Boulder, Colorado, and to Stanford and so forth. So it was just one of the problems was that the original ARPANET had a maximum of 255 nodes. And so some things had to change through that RFC process to say we need a real TCP/IP, standard, and we need more addresses. So IP version 4 was created so that we could have as many addresses as we have now, which apparently
Is not enough.
Yeah, not enough. So, does that answer your question? Somewhat?
Sort of, yeah.
Okay.
Yeah.
One of the books that I found that goes through a lot of this really well is called Rebel Code. And let me see if I can find the... Yeah, this is it. So if you're interested in this stuff, this book is excellent. There's a lot of other books that go into some more stuff in more detail, but if you want a really good overview of how Linux was born and some of these other projects like Apache and things like that, this book is great. Any other questions? Thank you for coming.